Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. In the last few episodes we've been adding a lot of new items, enemies and other features to the game, but we've cut some corners along the way. The copying and pasting of code is the biggest offender that I would like to address today. So what we will do is we will move a lot of shared code to our active superclass, and we'll make use of that superclass wherever we can. In addition, we will close off the episode by really completing Duke's shooting animation by including a muzzle flash and bracing animation when he's standing still. Let's go. All right, let's start out by making our movement code a bit more consistent across Duke and all the active classes. So what we'll do is we will add the velocity stuff to our active class. So we have the velocity X and the velocity Y. And let's go into Duke here, and let's see. Let's first start with the update the gravity actually. So let's see. I think we should probably move these getters a bit more to the bottom. All right, and then let's make a method that applies gravity. And then for now, let's just say that we always set our velocity y to 8. And let's go to Duke and let's copy the vertical movement and the horizontal movement code. I think that would be pretty nice. So here, let's take these two. Let's copy them first and paste them in. So, all right, so we also need width and height. So we have X, Y, and we have protected in width and height. And let's say that the velocity start out at 0. And let's say that the width default values to 15. Okay, so now we got some default values for everything. Let's make a getter for the width. And then here, let's use our new variables. So we don't have jump frames, but we do have the bump land methods. And then here we have the velocity greater than 0. Let's set the state to falling. We don't have to do that here at the moment. All right, so this will enable our active classes to be able to have gravity and horizontal and vertical movement. So let's go down into Duke and let's go check out where we have our update code, and let's just have it similar. So in the update code, we just say these things, and let's just do that for each active object by default. So we have the state get level and the state get level. Okay, so now let's have our boxes fall down. So we're overriding the update method here. So let's just go super.update, make sure that we perform the movement. And then here we have some bolt code, which we'll take a look at that in just a second. Okay, and where was the other gravity stuff? Here in the tech bot. So we can also go ahead here and also say like, okay, let's just always do a super update to at least have the movement done. But for that, we need to fix our try move stuff. So here in the try move, instead of move to, we can just set some velocity. So we'll probably have to change the stuff a little bit here. But let's just update our velocity X to being X minus the destination. So that means that if we're moving left, then destination will be, so I need to do destination minus x. And then this way, I think our robot should still move left and right. Yeah. Okay, we'll take a look at that in just a second as well. But because basically this try move method should set the correct velocity rather than the destination. But for that, we probably have to change this code a little bit later on. But for now, this is fine. So we got our gravity code shared a bit better now. So let's also do that for these items. So we make sure that the items are able to fall down as well. So these footballs should now be lying on the floor here. Yep, they are. All right, so we've unified the movement code and gravity stuff. This also means that now Duke can extend from active. And we can strip out some of these double defined things. So we need to make a constructor that sets Duke's initial position to 0, 0, I suppose. And we need to set the width, the height to 31. And then we can drop these static and just go ahead and take our own width and height. So these are the move functions that we actually defined somewhere else. The only thing we need to keep is this velocity check here to make sure that we keep the state to falling. We are overriding the gravity function because we can jump. So gravity behaves a bit differently for us when we jump. Get X no longer needed, get Y no longer needed. And these are all keyboard things. These we need to override because they're controlled from our superclass now. Okay, we can also move this collision check to the superclass, but for now we need to set our falling state. And let's do that just before we apply gravity. These have to be protected so that we can actually call them from our active class. We could, of course, also just do super.update here. And in fact, I think we should, to make the horizontal vertical movement. Although we have our, we cannot do that because we need to do a check in between to check for our fall state before we apply the gravity. So for now, this is fine. So this reduces a lot of duplicate code. All right, so we have Duke get width, Duke get height. All right, so this was a pretty major refactor. So let's see if Duke still behaves properly. All right, so the collision detection seems to be fine still. But we don't collide properly with our items anymore. So let's go ahead and fix that real quick. So let's move this collides with method to our superclass as well, so that any active can collide with any other active. So I think I'll just overload this method here with a second one, just to make things a bit easier. Active, active, return collides with active X, Y, width, and height. All right, and then we saw that the item collision, did not work because we are collides with this. We don't need the size anymore, but we do need to set our width. No, we don't, because that's the default. So let's just remove this right here. All right. So let's see if this fixes things a bit. Nope, we still cannot pick up objects. And why is that? We have equalize width, this x width. Yeah, okay, we need to do this width. There we go. That's so our collision detection was referring to the wrong width and height. So now we can shoot stuff again. Pick stuff up again. Okay. So that reduces a lot of duplicate movement and collision checking code. So let's see, what else can we clean up now? Yeah, we can say if Duke collides with this, and then here the Acme sign. We can also fix this one. Let's see, the check drop needs to stay, the shake needs to stay, but then fall basically is, I guess we should just update the game state. So what we can do here is just always call super.update. And then in fall, all we got to do is say that velocity y equals the fall speed. Or I guess we can just override apply gravity. And then only apply gravity if our state is falling. Then we have a velocity. And then we can just override the land function to say our active is false. Then we no longer need crash. All right, but this will probably, all right, so if we're falling, then I guess we'll just update per usual. Update state, super update state. So I'm guessing if we're falling, it's going to do collision check for the entire box. So it will get stuck and then it will say like, oh, I've landed. So what we need to do is we need to slightly change, optimize even our collision code. Yeah, so this is not used anymore, so I can inline this guy here. And then I'll just do active get X. Active get X. Active get Y. Active get Y. Yeah, so we need to update our collision detection code a little bit. What we want to do is only check the cells in the direction that we're going. So in order to do that, we should change our code a little bit here. So let's do a Boolean collision equals false. Let's calculate the row that we want to be in. So the row is our y divided by the tile size, and our column is x, new position x, divided by the tile size. And then what we want to do is, while there's no collision, and let's see, when we move horizontally, we want to check a complete column, all the rows in the column. So we want to go across a couple of rows. So while the row is less than y plus our height divided by the tile size. So while these two conditions are true, then we will go to level here and we'll create a new public Boolean is solid row column. And then what we'll do here is take this and return that. And then here, do this. So now what we can do is we can say collision is level is solid row column. And since we're checking rows here, we need to increment the row. All right. And then here we can check if we have a collision, then we'll just invoke the hit wall function. And if there's no collision, then we'll move to our new position. And then let's make our hit wall function here. No implementation for the active class by default. Okay, let's test if our horizontal collision check still works. All right, not quite. Because we have to do equal to, so that we actually check both cells and not accidentally skip. All right, so this is looking good. I can walk a bit too far inside of this one. And that is because we have, of course, a direction that we're going in. So that means that our our column is our new position X, and we might have to add our width if our velocity is greater than 0. Then we want to add width, and otherwise we don't want to add the width. So that we check either the left side of our bounding box or the right side of our bounding box, depending on which direction that we're going. Yeah, so this is looking pretty good. All right, and then we can modify our vertical movement function similarly. We already do a lot of stuff here, yeah, so we can do the same stuff here. So int, what we do first, row, yeah, okay. So our row equals our new position y plus our velocity y is greater than 0. We want to add our height, and otherwise we don't. And then divide that whole thing by the tile size. And yeah, let's also add parentheses here. Oh. And then our column is just our X position divided by the tile size. And then we can say, well, there's no collision, and now because we are checking either the upside or the downside of our bounding box, we want to check across a couple of columns. So column is less than column plus our width, less than or equal to. Let's not make the same mistake. Column plus our width divided by the tile size. Then we can say, okay, collision equals level is solid row column. And then we want to do column plus plus. All right, and then here we can say if there's a collision, just do the basic stuff that we always done. Okay, so now vertical collision should still work. And it doesn't anymore. All right, let's see, what am I doing wrong here? So we got a collision. So this is all just fine still. And then let's calculate a new row. That is still fine. And then we calculate our column. And then while there's no collision and our column is less than X plus our width, then we check for a collision. Okay, so I think this should have fixed it. Yep. Okay, so let's see, I forgot to reinstate setting jump frames to 0 when we bump our head. So let's go into Duke and let's find our bump method here, and let's say jump frames left. This used to be part of our vertical collision check, but now it should be part of our bump handling. Yep. All right, and now you can see finally, because we are checking collision only in the direction where we're going, that the Acme sign actually fell down. So I'm pretty happy with this. So that is a good first refactoring. So now the movement and the gravity and the collision detection is all handled from one superclass, which I think is pretty cool. Let's also go into our bolt class here, and let's remove this hitbox. We don't need it anymore because we have now put in the collision detection between active classes in the superclass as well. What it does mean though is because our XY value now represents our hitbox top left, we need to offset this Y variable where we spawn the bolt. So here we need to add 8, and then we need to not forget to subtract 8 when we draw the bolt again. So let's go to the render function for the bolt and let's subtract 8, because now our graphics origin is going to be different than our bounding box origin. Let's remove this hits function. We can just use collides with. And let's remove the hitbox, and let's remove this hitbox and this one here. And we can use state get level is a solid row call here rather than this stuff. And I might, this collision detection is a bit different than the default one because the bolts seem to behave differently colliding with the geometry than everything else. So for now, I'm gonna keep this. Maybe I'll try and unite this as well with the velocity stuff in the superclass, but I'm not too sure yet. For now, we were doing stuff with the bolt hit detection. So let's see, we have some compile errors now. So let's also move this into the superclass as well. Yeah. So let's take this out. Let's go into active and let's go into our update method. And then let's just go here and then let's say for bolt state get bolts. And then we can say if a bolt collides with this, then we can say bolt hit, and we are hit as well. And we probably need the game state in the hit, looking at this code here. So let's make a hit function, protected void hit, game state state. And now a box can override the hit method. So here we can just say, okay, if we're hit, then the bolt hit is already called. So all we got to do is spawn some contents and yeah, remove ourselves from the level. Okay. So each active class now actively checks if it's being hit or not, which I don't think is actually correct because not everything can be shot. Like items, you can just shoot through them. So I think what we should just do is make a separate function that check hit. And then any active class that is interested in being hit can just call it themselves. It's probably better. So let's just say super update state, and then let's just check for a hit. And then that will call this hit function in case of a hit. So that means now that cameras can be hit as well. So here, cameras don't move, so we're not going to bother calling the super update, but we do want to check our hit. And then override hit. If we are hit, then we'll increase the score by 100 and we'll set the camera to false so that we will be destroyed. Now the Acme sign is also able to be hit as well. So yeah, I guess it's time now to, let's just check hit here. It doesn't really matter which state we are in, because if it's in a different state, we cannot hit it anyway, because it'll be inside of the walls. And then let's just say hit state, increase score by 500 points, whatever. And the tech bot has a super update, and here we have a check hit function by the looks of it. And we have a hit function here that should take in a game state, which set us to explode. All right, now we should be able to shoot all this stuff. So yeah, I'm scoring more and more points here now. So that's pretty nice. Okay, so I think this is a definite improvement of our of the code duplication that we had. So I'm very happy with this. Let's finish this episode up by adding a new feature. Let's give the bolts and the shooting in Duke the final touch that it needs, because when Duke shoots, he like moves his leg, and there's going to be a muzzle flash at the end of the gun. So let's go ahead and implement that real quick. So what we need to do is we need to keep track of if we are pulling the trigger or not. So let's just change Duke's fire method. So let's give it a trigger pulled, and let's have a trigger pulled field. All right, and then let's have this old fire method, let's remove it. And then let's go to our update method. Render here. All right, so let's just go all the way to the bottom, and let's say that, okay, if the trigger was pulled and we can still spawn more bullets, then spawn it. So now our Duke's bounding box is different as well, so we need to fix where we spawn these bullets. So let's see, if we're facing to the right, we want to add the tile size. And if we're facing to the left, we want to remove the tile size so that the bullets will spawn in the correct coordinates. Okay, and then let's go to the bolt itself, and let's make a muzzle flash graphic for the bolt. So we'll default the frame. Let's just start at -1. So the very first frame, we can just do something else. And then let's go here, and then let's say buffered image sprite. And then if our frame is -1, then our sprite should be something else. So I'm just going to put in 0 here for now. Else our sprite needs to be the one that we are already doing. And then just draw. All right, let's figure out which one to draw. So let's go ahead, read the object file. Let's go to it, object.png. And let's run it. And then let's find object.png. There it is. And then let's find the muzzle flash graphic. And then here they are. This is to the left, to the right. And let's see, it's two images right next to the drumstick. So let's go to the item class, and the drumstick is tile 44. So that means it's 46 for the left and 47 for the right. So facing is left, then 46, otherwise it's 47. All right, so this should, in theory, give ourselves a muzzle flash. And it kind of does, but it's being drawn behind Duke, and it should draw in front of Duke. So let's go to GFX, and here we're drawing the bolts, and let's just draw them after that we've drawn Duke. So this should, in theory, draw the muzzle flash, and we can see it. All right, last thing to do is make his leg twitch a bit when he shoots. So we can go to Duke, and we can kind of do the same as we've done for the invincibility. So let's just override with a shoot tile. So if the trigger is pulled and we only do it for a standing state, then we need to have a different tile index. And then the question is which one? So for that we need to dump out the man graphics again. Man, read man. So left should be 4, 8, it should be 12. To the left should be 12. And then to the right. And then to the right it should be 4, 8, 12, 16, 20, 24, 28. Should be 28. This has to be it. To the back and to the front. All right, I think that about does it for this episode. We came a long way. We've fixed all the duplicate code that we had. We fixed some of the graphics that we had left in the shooting. So for next episode, I'm guessing we're going to do something a little bit more exciting, and we're going to add all the special effects, like the particle effects that the game has. So, you know, when something gets shot, like there's puffs of smokes and sparks flying and all kinds of particles going across the level. So we will be doing that next episode. Hopefully you'll join me for that one. If you have any questions, then feel free to put them in the comments down below. If you like the series so far, then hopefully you can give it a like and maybe a subscribe. And I'll see you guys in the next one. Bye-bye.